Your past isn't gone. Your future already happened. And everything you think you know about the flow of time is an illusion. This isn't philosophy or wishful thinking. It's what our best physics tells us about the nature of reality itself. According to our best physics, this isn't science fiction. It's the block universe theory, and it suggests that past, present, and future all exist simultaneously in a four-dimensional structure that physicists call spacetime. And what if the moment of your death already exists too, waiting in some other coordinate, just as real and present as this moment you're experiencing right now? This isn't about doom. It's a puzzle we can explore together. Now, I know this sounds impossible. Everything in your daily experience tells you that the past is gone and the future hasn't happened yet. You feel time flowing from moment to moment, like a river carrying you forward. But today, we're going to explore why some of the smartest people in science think this common sense view might be completely wrong. We're going to journey into a universe where all of time exists at once, where your past and future are as real as this present moment. This idea emerged from Einstein's theories of relativity, but its implications go far beyond anything Einstein himself fully anticipated. We're not just talking about time moving at different rates for different observers. We're talking about the possibility that time, as we experience it flowing from past to future, might be nothing more than a persistent illusion created by our consciousness. Think about this for a moment. Every memory you have of your childhood, every plan you're making for next week, every sense you have of moving forward through time, all of it might be based on a fundamental misunderstanding of how reality actually works. The block universe suggests that all of time exists as a single, static structure. Your first day of school exists. Your wedding day exists. The day you'll retire exists. They're all equally real, positioned at different coordinates in this four-dimensional block, just like different cities exist at different coordinates on Earth. Before we dive deeper, I want you to pause and think about this. What does it feel like when you remember something from 5 years ago? Does that memory feel less real than this moment right now? Now imagine that 5 years ago is just as real as right now, just located in a different part of space-time. How would that change the way you think about your life, your choices, your regrets? What about the people you've lost? In the block universe, they're not gone. They're just existing in a different temporal location. Does that bring comfort, or does it make their absence feel even more mysterious? Keep these feelings in mind as we explore what physics tells us about the nature of time itself. To understand why physicists think the past still exists, we need to start with a simple question that turns out to have a revolutionary answer. What does it mean for two events to happen at the same time? For most of human history, this seemed obvious. If you and your friend both looked at your watches and they both read 3:15, then obviously those moments occurred at the same time, no matter where you were in the world. This intuition is so strong that we built our entire understanding of cause and effect around it. We assume there's a universal now that sweeps across the universe like a cosmic clock, separating past events that have already happened from future events that haven't happened yet. But Albert Einstein showed us that this common sense view is wrong. And when I say wrong, I don't mean slightly inaccurate. I mean fundamentally, completely wrong. Let me give you a concrete example you can picture clearly. Imagine you're standing exactly halfway between two trees on a perfectly straight line. Lightning strikes both trees at the exact same moment. From your perspective, the light from both strikes reaches you at the exact same moment, so you conclude they happened simultaneously. Makes perfect sense, right? But now, imagine your friend Sarah is on a train moving toward one of the trees at high speed. From her perspective, she's racing toward one flash of light and moving away from the other. Now, you might think this is just about the time it takes light to travel different distances. Sarah is closer to one lightning strike and farther from the other, so naturally she sees them at different times. But here's where it gets weird. Even if Sarah accounts for light travel time, even if she does all the mathematics perfectly and corrects for every possible effect, she will still conclude that the lightning strikes happened at different times. Let me be crystal clear about this. You both measured correctly. You both used perfect instruments. You both did the math right. And you completely disagree about when things happened. According to Einstein's special theory of relativity, you're both right. There's no cosmic referee that can settle the disagreement. Sarah genuinely observes the lightning strikes happening at different times, while you genuinely observe them happening simultaneously. This isn't just a theoretical curiosity. The effect has been measured countless times with incredible precision. At the Large Hadron Collider, particles moving at 99.99% of the speed of light experience time so differently that physicists have to account for these effects in their calculations, or nothing would work. GPS satellites orbiting Earth move fast enough and experience different gravity that they experience time differently than we do on the surface. If we didn't correct for these relativistic effects, GPS would be off by miles within hours. Your phone's navigation depends on Einstein being right about the relativity of time. At everyday speeds, these effects are tiny smaller than the blink of an eye. But as speeds approach the speed of light, the disagreements become dramatic. Two observers moving relative to each other at 90% of light speed could disagree about simultaneity by hours for events happening across a city. So who's right? Did the lightning strikes happen simultaneously or not? Einstein's answer shocked the world. There is no absolute simultaneity. There is no universal now that everyone agrees on. Time itself is relative. If this shifted how you think about time, a quick like tells me to go deeper. This discovery, the relativity of simultaneity, completely changes how we think about existence itself. Let me show you what I mean. Physicists visualize this using something called a spacetime diagram. Think of it like a map, but instead of showing different places, it shows different times and places together on one grand chart. Your birth is a point on this map. Your first day of school is another point. Your first kiss, your graduation, this moment right now as you're listening to these words, each is a distinct point. Your entire life is like a trail of footsteps across this four-dimensional landscape. Now, here's the key insight that changes everything. In the old way of thinking, Newton's way, everyone had to slice this map the same way. Picture it like cutting a loaf of bread into perfectly horizontal slices that everyone agreed represented the same moments across the entire universe. But Einstein showed us that if you're moving, you have to cut the bread at an angle. The faster you move, the more tilted your slice becomes. What you consider now includes events that others would say are in the future or past. Let me break this down with something you can relate to. If you start walking toward your kitchen right now, your slice of now tilts. Events that were in your future a moment ago suddenly become part of your present. The effect is tiny for walking speeds. We're talking about differences smaller than the blink of an eye, measured in trillions of seconds. But it's real and measurable with the right instruments speed up to half the speed of light, and events a light year away that were previously in your future would suddenly be in your present. Walk around your room in a circle at that incredible speed, and your slice of now tilts wildly like a ship's deck in a storm. At the edge of the observable universe, your present moment would veer back and forth by centuries with each step you take. Ancient civilizations would flicker in and out of your now as you change direction. This effect, the relativity of simultaneity, has been confirmed by countless experiments. Particle accelerators, GPS satellites, even the decay of particles in cosmic rays all confirm that different observers genuinely disagree about when events happen. But here's the question that will keep you awake tonight. If there's no universal now, then which present moment is the real one? Whose perspective on time is correct? I can see this might be making your head spin a little. Einstein himself struggled with these implications for years, and they continue to puzzle physicists and philosophers today. If you like calm, clear, deep dives like this, subscribe for more. Now I want to show you just how strange this gets with a thought experiment that will challenge everything you think you know about existence. You and I are sitting in the same room right now. Our clocks read the same time. Everything seems perfectly synchronized. We're sharing this moment together, experiencing the same now. But imagine an alien spacecraft flying past Earth at 99.9% of the speed of light. The alien pilot has instruments just as precise as ours, maybe even better. They're measuring time just as carefully as we are, following all the same rules of physics. Here's the strange part. From the alien's perspective, they're now. Slice cuts through space-time at such an extreme angle that it includes events from what we would call the distant future. Let me make this concrete. If that alien is moving toward the star Alpha Centauri, which is about 4 light-years away, their present moment could include events happening on a planet around that star several years in what we call the future. From their perspective, they could theoretically observe your retirement party, your grandchildren's graduation, events that won't happen for decades from our point of view. Your future could be part of their present moment. But here's the question that changes everything. If that future is part of someone else's present, doesn't that mean it already exists? Think about it this way. How can the alien observe your future if it's not real? How can something that doesn't exist be part of anyone's present moment? If we accept that the alien's present is real, and Einstein's relativity says we must, then your future must be real too. This is where the block universe theory comes in. It suggests that all events in space-time, past, present, and future, exist equally. Your future isn't something that will come into existence when you get there. It already exists, just positioned at different coordinates in the 4-dimensional structure of space-time. Here's an analogy that might help. When you look at a distant mountain, you don't think the mountain exists less than the ground beneath your feet just because it's far away. Distance in space doesn't affect existence. In the block universe, future events are just far away. In the time direction, instead of a space direction, they're equally real, just positioned differently in the 4-dimensional landscape of space-time. The technical term for this view is eternalism. The idea that all times are equally real. Its opposite is presentism, our common-sense view that only the present moment exists, with the past gone and the future yet to be created. There's also a middle ground called the growing block theory, which says the past and present exist, but the future doesn't yet. Picture reality as a growing crystal, with new moments crystallizing into existence as time passes. But even this compromise view runs into problems with relativity, because different observers disagree about which events are in the future. If your future can be someone else's present, and if we accept that their present is real, then your future must be real too. Einstein's relativity seems to push us toward eternalism. If all reference frames are equally valid, which is a cornerstone of relativity, then we have to accept that all the events they consider present are equally real. Let me pause here and let that sink in for a moment. This means that maybe all moments in time exist equally. Every moment of your life, past, present, and future, might be equally real, just positioned at different coordinates in space-time. In the block universe, every moment of your existence is eternal. The day you were born, your first day of school, your first kiss, your biggest failure, your greatest triumph, they're all equally real forever. You're not just remembering your past. In a very real sense, you're still living it. Your 10-year-old self isn't gone. They're just located in a different region of the four-dimensional block. Like how your friend in Tokyo isn't gone just because you're currently in New York. And your future self? They exist too, somewhere ahead of you in the time dimension. They're living their life, making their decisions, experiencing their joys and sorrows, just as real as you are right now. Now, I know what you're thinking. This raises some deeply uncomfortable questions about choice and free will, and you're right to be concerned. If your future already exists somewhere in the block universe, do you really have any choice in what happens next? Or are you just playing out a predetermined script that's already been written in the fabric of space-time? Let me give you a way to think about this that might help. Imagine watching a movie for the second time. The characters on screen seem to be making choices, experiencing emotions, facing real challenges and dilemmas. But you know how everything turns out. From your perspective outside the movie, all the events already exist. They're encoded on the film or in digital memory, yet the characters' choices still feel meaningful within the story. Their decisions still flow from their personalities and values. In the block universe, we might be like those movie characters. We experience making choices because that's what our part of the four-dimensional structure contains. Our decisions feel real and meaningful to us because they emerge from who we are. But here's something important to consider. Even if your choices already exist in the block universe, they're still your choices. They still emerge from your thoughts, your values, your personality, your unique way of processing information and making decisions. Think about a decision you made yesterday. Maybe what to have for breakfast, whether to call an old friend, or how to respond to a difficult email. In our normal view of time, that decision was made in the past, and now it's over and done with. But in the block universe, that moment of decision exists eternally. Your past self is still there, still weighing the options, still going through the mental process of choosing, forever. They're not remembering making the choice. They're making it. Right now, in their coordinate of space-time. The fact that the choice exists forever in space-time doesn't make it any less yours. It's still the result of who you are, how you think, what you value. The decision still flows from your personality and reasoning process. Some philosophers argue that this worry about free will is misplaced. They say that choice and responsibility don't require the ability to change a future that doesn't exist yet. They just require that our decisions are truly ours, emerging from our own deliberation and values. But others find this unconvincing. If your entire life story is already written in the structure of space-time, how can you meaningfully change anything? How can you improve yourself, learn from mistakes, or make different choices? Consider someone struggling with addiction. In our normal view of time, they can choose to get help, change their behavior, work hard to overcome their problems, and create a better future. Their effort and determination can make a real difference. But in the block universe, their entire struggle, including whether they overcome the addiction or not, already exists in the four-dimensional structure. Their recovery or relapse is already fixed in space-time. Does this make their struggle meaningless? Or does it just mean that their struggle, their growth, their eventual success or failure are all eternal parts of who they are across space-time? Some people find this view troubling. Others find it strangely comforting. It means that every moment of love, every achievement, every time you've helped someone, all of that exists forever. Nothing beautiful is ever truly lost. Your best moments with family and friends exist eternally. Your greatest accomplishments are permanent features of reality. Even your struggles and growth have eternal significance. I'm curious what you think about this. Does the idea that your choices might be fixed in space-time make you feel trapped? Or does knowing that your best moments exist forever give you a strange kind of peace? Take a moment to think about it and let me know in the comments what this means to you. But before we accept the block universe completely, we need to address something that seems to argue against it: the fact that time has a direction. You see, there's something peculiar about our experience that the block universe struggles to explain. While the theory says all moments exist equally, we never see certain kinds of events happen. You never see eggs unbreaking, smoke flowing back into a fire, or people growing younger. Time seems to have a preferred direction, and that direction is always toward increasing disorder. Let me show you what I mean with something simple you can try at home. Drop a splash of cream into your coffee and watch what happens. The cream spreads out, mixing with the dark liquid until it's uniform. The cream molecules start concentrated in one small region, but thermal motion quickly disperses them throughout the coffee. In just a few seconds, you go from organized to mixed. You'll never see the reverse cream spontaneously separating from coffee and forming a perfect white droplet, not because it's impossible according to the fundamental laws of physics, but because it's so monumentally improbable that you'd have to wait longer than the age of the universe to see it happen. Time flows for us. The universe itself simply is. This is what physicists call the arrow of time. It's connected to something called entropy, which is basically a measure of how mixed up or disordered things are. In our universe, entropy tends to increase, giving time its direction. Think about other examples. Hot objects cool down by spreading their heat to cooler surroundings. Mixed things don't spontaneously unmix. Broken things don't spontaneously repair themselves. Ice melts, but puddles don't spontaneously freeze. This is the second law of thermodynamics in action. In any closed system, entropy disorder tends to increase over time. This gives time its arrow, pointing from ordered states toward disordered ones. But here's the mystery. If the block universe is real, why does this arrow exist at all? Why don't we experience time flowing backward just as easily as forward? Why don't we see events running in reverse? The standard answer has to do with how our universe began. The Big Bang appears to have started everything in an extremely ordered, low-entropy state. All the matter and energy were concentrated in a tiny, hot, uniform region. Ever since then, entropy has been increasing as the universe expands and cools. Gravity clumps matter into stars and galaxies. Nuclear reactions in stars create heavier elements and radiate energy into space. And eventually everything will disperse into a cold, empty space filled only with fading radiation. This cosmological increase in entropy gives us our perception of time's flow. We remember the past because our brains are complex, low entropy structures that can record and store information. We can't remember the future because the increase in entropy makes the future fundamentally unpredictable from past information alone. But this raises a profound question. Why did the universe start in such a low entropy state? This isn't just a minor detail. It's crucial for explaining why time has a direction and why we can remember the past, but not the future. If the universe had started in a high entropy state, everything would have been random and disordered from the beginning. There would be no arrow of time, no clear distinction between past and future, and probably no life or consciousness to contemplate these questions. Some physicists think the answer lies in the nature of the Big Bang itself. Perhaps there's something about how universes begin that naturally creates low entropy initial conditions. Maybe the laws of physics themselves conspire to start time with a clear direction. But physicist Julian Barber has proposed something even more radical. What if our universe doesn't have a beginning or an end, but a middle? Barber suggests there might be a point of minimum entropy, what he calls the Janus point, named after the Roman god with two faces, from which time flows in both directions. Imagine the block universe, not as a loaf of bread, but as a mountain with a peak in the middle. From this peak, entropy increases in both the direction we call the past and the direction we call the future. But here's the twist. There might be conscious beings on the other side of this point who experience time flowing in the opposite direction from us. To these beings, what we call the past is their future, and what we call the future is their past. They remember events that we consider to be in the future, and they anticipate events that we remember as the past. From their perspective, stars are condensing out of dispersed gas, people are growing younger, and broken eggs are spontaneously assembling. They would see our universe as running backward, just as we would see theirs. This would mean the block universe isn't just a static structure, it's a dynamic one, where consciousness can experience the same events from opposite temporal directions. The same cosmic history could be lived forward by some beings and backward by others. But perhaps the most intriguing possibility is that time might not be fundamental at all. It might be what physicists call an emergent property, something that arises from simpler components even though the components themselves don't have that property. Think of wetness. Individual water molecules aren't wet, but collections of them create wetness. Individual neurons aren't conscious, but networks of them give rise to consciousness. Similarly, individual moments might not have time, but collections of them might create the experience of time passing. Some of our most advanced theories of quantum gravity, including the Wheeler-DeWitt equation, don't include time as a fundamental variable. In these formulations, the universe exists in a timeless quantum superposition of all possible states. Time might emerge only when you divide the universe into subsystems and ask how one subsystem evolves relative to another. The flow of time could be a consequence of how quantum information becomes entangled across different parts of the universe. Here's a way to picture this that might help. Think of a movie. Each individual frame is static. No motion, no passage of time. But when you play them in sequence fast enough, the illusion of time and change emerges from the relationship between frames. The motion isn't in any single frame. It's in the sequence. Could our experience of time be similar? Could consciousness be like a movie projector, creating the illusion of temporal flow from static moments in the block universe? This idea gets even stranger when we consider quantum mechanics more carefully. In the quantum world, particles can exist in multiple states simultaneously, what physicists call superposition, until they're observed or measured. Some interpretations of quantum mechanics suggest that consciousness plays a fundamental role in collapsing these quantum superpositions into definite realities. The act of observation somehow selects one possibility from many, turning potential into actual. Quick flag. What follows is a hypothesis, not settled physics. If consciousness helps select definite outcomes from quantum possibilities, and if time emerges from quantum processes, then your awareness might not just experience time, it could shape our experience of its flow. Recent research in quantum foundations suggests that quantum entanglement, the phenomenon where particles become mysteriously connected across vast distances, might be the source of emergent time. When particles become entangled, they form correlations that seem to operate instantaneously across any distance. Einstein called this spooky action at a distance, and was deeply uncomfortable with it. But experiments have confirmed that quantum entanglement is real and defies our classical intuitions. Some physicists now think that time itself emerges from these quantum correlations. The idea is that entanglement creates a web of relationships between different parts of the universe, and the evolution of these relationships is what we experience as the passage of time. In this view, time isn't woven into the fabric of reality. It's more like a pattern that emerges when quantum systems interact in complex ways. The block universe might not be a fixed structure, but rather a dynamic network of quantum correlations evolving according to the laws of quantum mechanics. This would mean that the past, present, and future aren't equally real after all. Instead, reality might consist of an evolving web of quantum possibilities, with time emerging as consciousness navigates through this web of potential outcomes. But even this emergent view of time has to grapple with the relativity of simultaneity. If time emerges from quantum correlations, why do different observers still disagree about simultaneity? Why doesn't everyone experience the same emergent time? The answer might be that consciousness itself is relative. Just as there's no absolute simultaneity in space-time, there might be no absolute consciousness. Each observer creates their own version of emergent time based on their unique quantum interactions with the universe. This brings us full circle to one of the deepest questions in science. What is consciousness, and how does it relate to the physical universe? If the block universe theory is correct, then consciousness might be the thread that weaves through the four-dimensional structure, creating the illusion of temporal flow. We're not separate from space-time, we're patterns within it, experiencing our own existence from the inside. But if time is emergent from quantum consciousness, then we might be the authors of time itself, creating the temporal structure of reality through our observations and interactions with the quantum world. So where does this leave us? Are we living in a block universe where all moments exist eternally? Are we experiencing an emergent illusion created by quantum consciousness? Or is time somehow more fundamental than either theory suggests? The honest answer is that we don't know yet. These are some of the deepest and most difficult questions in all of science, touching on physics, neuroscience, philosophy, and the nature of existence itself. What we do know is that time is far stranger and more mysterious than our everyday experience suggests. Whether we're eternal patterns in a block universe or conscious creators of emergent time, we're certainly not what we appear to be. The block universe theory challenges our deepest intuitions about reality. It asks us to consider that our past selves still exist, that our future is already real, and that our sense of flowing time might be an illusion. If your past self still exists somewhere in space-time, how does that change how you think about memory and identity? If your future is already real, how does that affect your approach to decisions and planning? If consciousness creates time, what does that say about the nature of reality itself? These aren't just academic questions. They go to the heart of what it means to be conscious beings in a universe that might be far stranger and more wonderful than we ever imagined. But here's what I find most remarkable. Regardless of which theory is correct, your experience still matters profoundly. Your consciousness, your relationships, your growth as a person. These things have deep value whether they exist in an eternal block or emerge from quantum processes. The universe may be stranger than we can suppose, but it's still our universe. We're still conscious beings, capable of wonder, love, discovery, and growth. Whether time is real or illusory, whether the future exists or emerges, we're here now, asking these questions and marveling at the mystery of existence. Watch next. Brain scans reveal impossible truth about consciousness. If the block universe made you question the nature of time, consciousness research will show you how your brain creates the illusion of the present moment.